Hello, Year 11s. I hope you're doing well. Here's your physics work for today. Now, there's a lot of building work going on, so I do apologize for the sound effects going on around me, but hopefully you'll be able to follow this nicely. So in our last physics lesson, we looked at melting ice, and it took forever for the ice to melt, and hopefully in the next couple of minutes, you'll understand why. But you will have remembered that we did an experiment where we were measuring the temperature of the ice every minute for about 40 minutes, and you saw what little change there was in that time. Now, if we left this for long enough, what we will notice is a graph that looks something like this. And over the course of this lesson, hopefully we're going to explain exactly why there are those flat parts. But to help you start with your thought process, you can notice that there's a flat part for heating ice, which is H2O, at 0 degrees Celsius and 100 degrees Celsius. And yes, you're absolutely right. Those are the melting points and the boiling points for that substance. So any substance that I heat up, there will be a melting point and a boiling point. And if I didn't know that this was water, by doing this experiment and seeing that the melting and the boiling point was 0 degrees Celsius and 100 degrees Celsius, I can totally confirm that the substance I'm dealing with is water. Right, so no need to write anything down yet. I'll tell you exactly when you need to do this. Okay, so just a couple of ideas about this. When the graph is actually going up, that is when the kinetic energy of the particles are increasing. So when it's flat, that's when the change of state is happening. But when it's going up at an angle, that is because the particles are gaining kinetic energy, and therefore the temperature of the substance is increasing. And of course, where it's flat and it's a change of state going, there's bonds being broken. So we're going from a solid to a liquid to a gas. And all that time, the energy is being used to break that force of attraction between the particles. Okay, and the same thing happening once we get to the boiling point. Okay, so no need to write anything down yet. We'll write a bit more down later on. So if I decided to heat this beaker, we know that the water will gain some internal energy and will start to get hotter. And the question is, what three things does the increase in temperature depend on? Now, you might want to pause the video here and just think what those three things can be. Have a little bit of a ponder. Okay, so what are the three things that the increase in temperature of this substance in the beaker depends on? The first one is the amount of liquid. Obviously, if I've got a huge tank of water, it's going to take longer to heat than if I have a little bit. And that's why we only put a little bit of water in our kettle if we just want enough for one. Otherwise, we've got to wait a long time for a whole full kettle to boil. The second one is the amount of heat energy going into the liquid. So for example, how hot is that Bunsen burner? You know, if I've got a very strong heat source, it will heat up a lot quicker. We know that with perhaps if we are barbecuing. And finally, the substance that's being heated. So for example, is it water or is it cooking oil? Okay, they will differ depending on the substance. So take a moment, pause the video, and copy down these points. Okay, now we can put these ideas into an equation like they love doing for physics. And this is what they do. They say if the rise in temperature depends on the mass of liquid, how much energy it's given, and the substance being heated, we can say that the change of energy, the triangle always means change, by the way, equals the mass times the C, which is the specific heat capacity for that substance, and the triangle with the O with the circle, that is a theta sign. It's from a Greek symbol. It means change in temperature. Okay, so over here we've got what all these things are. So water will have a specific heat capacity. Oil will have a specific heat capacity. Okay, and we're always interested in the change in temperatures, not necessarily what the actual temperature is, but the temperature difference that occurs. So pause the video so that you can copy out the formula, and for each of those variables, explain what it means and take note of the units. Okay, so here is a definition for specific heat capacity. The specific heat capacity can be thought of as the ability of an object to store heat energy. Okay, so we say it's the amount of energy needed to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. So if you can pause and write down that definition, please. Okay, so nothing like putting this into practice. What I would like you to do is see if you can, using the equation, remember the 3 steps, copy out the formula, substitute the numbers in, and give your answer with units. So I'd like you to copy out these 2 questions. So you've got 2 sample questions, and then show your working and your answer, and then we'll go through them. So pause the video to allow you to do this. Okay, Year 11s, let's take out your purple pen and let's see how you've done with these questions. So, the first thing you need to do is write out the formula. So, change in energy equals mc delta theta, and you need to know this equation off by heart. So, your mass from the question is 0.1 and it's in kilograms, so that's good. The specific heat capacity for water is always 4,200 joules. And they say the change in temperature, it goes from 20 to 80. So 80 minus 20 gives me 60. So I put that into the calculator and my answer should be 25,200 joules, or you can change it to 25.2 kilojoules. Right, so hopefully the next one challenged you a little bit more. This time you'll notice that they give you the mass in grams and not kilograms, and this is why you need to know what the standard international units are for your equations. So the grams have got to be converted into kilograms, 1,000 grams in a kilogram, so I'm going to divide by 1,000, and it says it starts at 50 degrees Celsius. It doesn't tell me my change in temperature, and it says if it loses 2,000 joules of energy, so that's my change in energy, what temperature has it dropped to? So I start off by writing my equation, and I then need to manipulate my equation so that I have delta theta on its own. So all I do is I divide by mc, so it's delta E, change in energy, divided by mc gives me the change in temperature. So if I substitute my numbers in, I've got 2,000 as my energy, and my mc, my mass, 24 grams is 0.024 kilograms, and because it's water, I know my specific heat capacity for water from the previous question is 4,200. So that gives me an answer of 19.84. That's my change in temperature. But the question says, what has the temperature dropped to? So if it started at 50, and the overall change is 19.84, I've got to subtract that, and I get an answer of 30.16 degrees Celsius, or if I do it to 3 significant figures, 3 significant figures, it's 30.2 degrees Celsius. Okay. Hope you did well then. If you've got anything wrong, just purple pen it so you've got a good worked example and a challenge example to go through. Now, how do we apply this? So sometimes we have heaters that are stored with, that have water stored in it, and sometimes we have heaters stored with oil in it. And it says here, which stores the most energy? Well, what we know is that different materials store different amounts of heat energy. That's the specific heat capacity. So if you look at the specific heat capacity for oil here, it's 1,970 joules per kilogram degrees Celsius. And the specific heat capacity for water is 4,200 joules to heat a kilogram of water by 1 degrees Celsius. So what we can see here is that the water, in fact, stores a lot more energy. So that will actually be storing the most energy to then release as heat into your lovely living room. The oil also will take longer to heat up. Okay, so there you go, a good application of specific heat capacity. Now, what I would like you to do is I would like you to complete this table, and this will help you to practice manipulating the equation. And then once you are done, you can purple pen your answers. So pause here and have a good go. Okay, you're 10, well done. So if you can now take out your purple pen, and what I'd like you to do is I'd like you to purple pen your answers. If there's any that you weren't sure of, please just email me and I will go through it with you. Okay, I'm going to next talk about latent heat. So when you are ready, if you go to the next video.